Welcome back to the video series lecture of PPS, and that is Programming for Problem Solving. My name is Jinal Jhala and I am your instructor of this subject. In previous video we had already started our 6th module, that is recursion, and in that video we had already seen two different examples. First example is print high for n times and second example is find a factorial of a given number. And today in this video lecture we are going to see one another example. So the definition of program is like write a program to print Fibonacci series for n numbers. This Fibonacci series you already learn in mathematics, but if you don't have any idea that what is Fibonacci series, then I am telling you just overview of Fibonacci series. So in Fibonacci series our first two digits are fixed. Suppose I am taking first number as a 0 and second as a 1, then how we can find the next third digit in our series? So just to do the addition of previous two number. So 0 plus 1 we will get answer 1. So 1 is our third digit in Fibonacci series. If you want to find fourth digit, then just find the sum of your previous two numbers. So our previous two number is 1 plus 1. So 1 plus 1 we will get 2. You can see on the screen the example I have mentioned here, that 0, 1. Then after 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8. In this way we can write our Fibonacci series. But here we have to do program for n numbers, means if I am enter n is equal to 5, then my answer is to print Fibonacci series up to 5 digits. Means first is a 0, second 1, third also 1, fourth 2 and fifth is 3. If I am enter n is equal to 3, then print the same series but only for 3 digits. So when you enter your n value 10, then print up to 10 digits. So start with very first step, and here for recursion we can build a program using user defined function. So our very first step is to write the function declaration. And how we can write here? So here we will use our third category of function, that function with argument and with return value, because here we have to return something. So I am writing integer as our return type because print only integer numbers, that's why. Then our function name. So I am writing in short FIB, short form of Fibonacci series. You can write any of your function name. And how many parameters are needed here? So I am passing only single parameter, integer n. So this first part is called as a function declaration. I am writing in comment line that function declaration. Now what is our next step? Write the main function. So I am writing void main. Now in main function how we can start the program? So here we have to do this process in repetition, and when we write integer as our return type, so at a time it will return only single value, but here we have to get multiple values. So in main function we can use one loop for start from 0 to n, and one n variable is required because we have to pass as a parameter. So I am writing one integer n, and second variable is used for loop. So I am taking one variable I. Now first of all our main task is to enter the value of n, means how many digits you want in your series. So write one printf function and write enter n, or you can say enter limit of your series, and simply scanf %d comma ampersand n. Now we can use for loop. So I am writing for I is equal to 0, I less than n, I plus plus. Why I 0? Because our series starting from 0 here. That's why I am taking our first value of I is 0. Now here we can write one printf function, and in printf I am writing %d, then comma, here we can call our function. So our function name is fib, and in bracket pass the value of I, because all time I will be updated. So first of all fib 0 will be called, then our I become plus plus, so fib 1 will be called, then again I plus plus, so fib 2 will be called. In this way our function will call. So this is called as a function call into our main function. Now our third part is function definition. So just write the definition. So now we have to think about our two cases. First is a base case and second is a recursive case. So when you can do addition of two numbers, first of all you have two inputs, then after you can do the addition of two numbers. So I am writing here first condition that if my n value is equal to 0, then simply return 0, because my first input in series is 0, that's why. Now for 1 we can use else if statement, because when you want to write more than one condition, then you can use the concept of else if ladder, nested if else, appropriate conditional statement you can use here. I am using else if statement. Now in else if I am writing for 1 that if else if n is equal to 1, in this case return 1 not 0. Why? Because after 0 our second digit is 1, that's why. And write last else part. And what we can write in this else part? So for that number I am writing fib n minus 1 plus fib n minus 2. So this part is called as a recursion. Why? Because here function calling itself, and here our two conditions are called as a base case. Now let's see how it will execute. First of all, if I am taking here n is equal to 5, then our loop start from 0, means I starting from 0 to I less than 5, means 5 times our loop will be execute. So first of all our I value is 0, and here we are calling the function that fib I. So one function call which name is fib 0. So when this function call, our control goes to function definition. So here n value become 0. Now check the condition. If n is equal to 0, yes, now our n value is 0. So it will return 0, and here this printf will execute, then 1 0 will be print. Now our I become plus plus, so I value become 1. Now again printf %d for fib I. So now our I value updated, that is 1. So fib 1 function call now. So our control goes to the function definition, means here. Now our n value is 1. So check the first condition, but now our first condition become false because n value is not 0. So check for another condition. Now our second condition become true, n is equal to 1. So it will return 1. So here second printf means second digit print, this value is 1. Now again our I become plus plus. So now fib 2 will be called. So for fib 2 our first condition and second condition both become false. So it will go in else part, and here in else part I am writing fib n minus 1 plus fib n minus 2. Now what is the meaning of this statement? Now our n value is 2. So one function call that fib n minus 1. So 2 minus 1 means 1 plus fib n minus 2. So 2 minus 2, 0. Again you can see that this function calling itself. So when fib1 will execute, so the answer of fib1 is 1. So here 1 plus, and fib0 function value is 0 because now n value is 0 for this function. 1 plus 0, we will get answer 1, and our fib2 function value, final value, we will get that is 1, and it will return here and print here 1. Now again our I become plus plus and I value become 3. Now our n value become 3, and for 3 these both the condition become false. So again it will go in else part, and for fib3, 3 minus 1 means fib2 function will call again, and n minus 2 means 3 minus 2 we will get answer 1. So fib1 will be called, and answer of fib2 already we know that is 1. So here it will return 1 and value of fib1. So fib1 value we will get the answer 1 again here. So here 1 plus 1 we will get answer 2. So the answer of fib3 will be 2, and 2 will be print here. Now again your I will be increment and I become 4. For 4 again your fib4 function call and go to the else part. So when your fib value is 0, then our first condition become true. When fib value is 1, then second condition will be true, and for remaining all the numbers our else part will be execute recursively. In this way we can find the Fibonacci series. Let's see the output. First compile the program and run the program. So enter the limit. I am entering 5. So you can see the output 0, 1, 1, 2, 3. Our Fibonacci series up to only 5 digits. Now let's see one another output. Enter limit. Suppose I am enter 7. Then you can see here our Fibonacci series up to 7 digit. Again run the program, enter limit. Suppose I am enter 10. So you can see here our Fibonacci series up to 10 digits. So in this way we can find the Fibonacci series using the concept of recursion. This same program we can build using loop, but recursion is the alternative of loop. Hope guys you understand this practical session very well. We will meet you in next module, module number 7, that is pointers. Till then, take care. Bye bye. Thank you so much.